This is Miss McKay, and now we're going to be working on the second part of our triangle inequality theorem examples. On this part, we're going to be finding a third side range. So for our examples, given two sides of a triangle, you can set up an inequality using the sum and difference to show the range of possible lengths of the third side. So we're going to look at two sides that are given, and we're going to find out what could the different lengths be on the third side, such that if you add 14 and 22, it's always going to be larger than that third side. So how you do it is like this. Okay, we'll start off with, all right, so first of all, it's not a difficult thing. Now, you have to write this as an inequality when you finish. So what you do is, and normally I set it up so that when I'm finished, the answer's already in its inequality form. But first thing you want to do is on an inequality, special compound inequality, the smallest value is always written to the far left. So what we're going to do 22 is the largest number, subtract the smallest number. Then we're going to write our less than symbol because it's always going to go in that direction. We're going to put an x for our variable because those are our possible third sides. And then we're going to say less than, and then we're going to say 22 plus 14. Okay. All right. So 22 minus 14 is actually an 8. 8 less than x less than. And then 22 plus 14 is 36. So our final answer is this right here. 8 less than x less than 36, which means you can pick any number bigger than 8 but smaller than 36, and it would be bigger. It would be the when you add the other two sides together, it would be larger than the third. So for instance, let's just say for instance I choose 10. 10's bigger than 8 but smaller than 36. So that means your three sides will be 14, 10, 22. I'm just showing you that this does work. So like we said in the last example, you took two smaller sides. And so 14 plus 10, is it larger than 22? And it is. Okay, so we know that's true. And then I'm going to pick another number. Let's say I pick 35. So we got 14, 22, 35. And in this case, we're going to pick our two smaller numbers. 14 plus 22, is it bigger than 35? And it is because it's 36 bigger than 35. But let's just say you pick that inequality and it says, okay, test aside, and you test 8. Okay, so let's say we test 8. I'm going to write it over here. But let's say we test 8. So we're just testing numbers. So I'm going to erase this real quick. So let's just say we tested 8. So I'm going to get that. Hold on. Right, so let's just say we tested 8. So then we're going to say 14, 8, 22. So our two small numbers are 14 and 8. So 14 plus 8 greater than 22. Well, that is 22. And remember, 22 can't be greater than 22. So that's why you can't pick 8. It's also the reason why you can't pick 36. You have to find numbers that are bigger than 8 and smaller than 36 so that it makes that triangle inequality true. Now, in our next examples, we won't be testing it, but I tested it so that you could see why that inequality works. So let's go to example 2, which is 3 and 11. Okay, so we're going to write out our inequality so that way when we solve it, it's already written in its final form. You always subtract first, and it's the larger number, subtract the smaller number, less than x, or any other variable you want to choose, less than 11 plus 3. So that's going to be 8 less than x less than 14. So that's our final answer. Your final answer is this, the inequality itself. Okay. Some people may say as an answer, I would say about 9 times out of 10, about 90% of the time, your answer is going to be written as inequality. But for that little low 10%, they may say, oh, it's a number that's bigger, greater than 8, but less than 14. Same thing, but written is going to be written out as a compound inequality. All right, let's look at example 3. Example 3 is 24 and 7. So in this case, we're going to do 24 subtract 7 less than x less than 24 plus 7. It'll work like this every time. So 24 minus 7 is actually 17 less than x less than 24 plus 7, which is 31. And that is your final answer. This is the answer. You don't have to do anything else. Once you complete that, that is your answer. And that's if they're finding the third range. If they say find the range to get the third side of a triangle, that is your clue. Oh, I'm subtracting, I'm adding, I'm writing as an inequality. Let's look at our last example. Okay, our last example says if a triangle has lengths of 15 feet and 27 feet, check all the possible lengths of the third side. Now this time we're giving different sides and we have to determine which ones work. And we're going to check off the ones that work. But in order to do that, the first thing you need to do is actually get the inequality itself. So here's our two sides we're given. So we're going to go ahead and set up our inequality. 27 subtract 15 less than x. Hold on a second. Less than x. My x won't form. And then 27 plus 15. Okay. So now 27 subtract 15 is 12 less than x less than 27 plus 15, which is 32. I'm sorry, not 32, it's 42. It's actually 42. Okay, so now our final answer is checking off which one of these fits inside of this inequality. So basically, you're going to choose all numbers that are bigger than 12 but smaller than 42. So we're going to look at 34. 34 is bigger than 12 and smaller than 42, so that's an answer. 12. 12 is not bigger than 12, so we can't choose that. 29 is bigger than 12 and smaller than 42, so that's an answer. 18. 18 is bigger than 12 and smaller than 42. And then 43. 43 is bigger than 12, but it is not smaller than 42. Has to be smaller than 42, so that's not an answer. So our three answers are 34, 29, and 18. Guaranteed you'll probably be asked a question like that on any assessment. All right, that's the end of this lesson on how to find the range of the third side of a triangle.